Good morning, everybody. Welcome to Year 4 Maths on this Wednesday morning. We're going to start this morning with the warm-up activity that we normally do. 5 questions. 2 of them are probably pencil and paper. 3 of them you might be able to have a go in your head using mental strategies. Get as close to 5 minutes as you possibly can. Press pause while you're working. Press play when you're ready to hear the answers. Okay, press pause now. Okay, first question this morning, we're going to look at 2 times 2 times 3. Okay, method 1 then, I would say multiply 2 by 3. So 2 3s are 6, and then multiply the number that you get from that 6 by the remaining number, which is 2. So 6 2s are 12. Second method, you could multiply the first 2 digits, so 2 2s are 4, and then multiply the last digit by 4. So 4 3s are 12. Either way, you get the same answer. Your choice, really. Okay, next question, 12 9s, straightforward times table question. Remember that multiplication is commutative, so if you do struggle with your 9s, maybe flip it around and have a go at your 12s. Either way, 12 9s, 9 12s, the answer is 108. Next question, 34 times 8. This is the second pencil and paper question, really. Method 1, I've used abstract method of short multiplication. I've columned up the numbers, making sure I've lined them up properly. 4 8s then, or 8 4s, are 32, and I've had to carry the 10 across to go underneath the 10s column. And then 3 8s or 8 3s are 24, plus the 3 will give you 27. So our answer there would be 272. Second method, as you all know, I like a good partition. Okay, so I'm partitioning 34 into 30 and 4. And then I'm going to say 30 times 8 is 240. And then 4 times 8 is 32. And then if I recombine those numbers, I'll be left with 272. Same answer as over here. Next question is one of those fraction questions. So adding fractions with the same denominator. Remember, I've stressed over and over again, when you are adding fractions with the same denominator, the denominator will always stay the same. You should only add the numerators. So here, I've got a fifth plus 11 fifths. So my denominators will stay the same, so stay as fifths. And my numerator will be 1 plus 11 equals 12. So the answer would be 12 fifths. Some of you might be able to say, okay, that would be 2 and 2 fifths. But as long as you've got 12 fifths, I'm more than happy. And the last question on this morning's warm-up, we've got 84 divided by 3. Now, I think the best way to do this would be straightforward, short division, abstract. 3s into 8 goes 2, because 2 3s are 6. And then I would carry the 2 remainder, the 2 that are left over, carry it over to the next digit. So that becomes then 24. And then we'll say 3s into 24 goes 8. So our answer then would be 28. And if I wanted to check that, a good way of checking it would be to take my answer, multiply it by the divisor, okay, the 3. If I multiply that by 3, I would get the answer 84. So it's a good way of checking it. Okay, moving on. Our learning intention for the main part of this morning's lesson is being able to classify triangles, to be able to identify properties of them, pick out which triangle is which, and say why. Okay, now our star words this morning would be classify, so sort, triangle, okay, that we all know a triangle is a 3-sided 2D shape, equilateral, which is a type of triangle, scalene and isosceles. They're all different types of triangle. Our in focus task this morning is asking, you've got there a range of triangles, and it says, how are these triangles alike and how are they different? So the knowledge we'll need for this, we're going to need to use some of the ideas that we had in the last lesson. So maybe things like acute, obtuse, right angle might come in useful. But we need to know all about different types of triangles to be able to answer this question. first job this morning is to look at different types of triangles, and I'm going to introduce you to the names for the names of all of these three different types of triangles. Now, the first one we're going to look at is this group here. Okay, now we're using all the triangles that we had in the in focus task here, and you can see that we've got two triangles in this section here, and the section says, in this part of the sorting diagram, says all three triangles are of equal length. So what that means is that they all have the same length sides. They're all the same. All three sides are the same length. Now, they are called equilateral triangles. Equilateral triangles. The prefix equa means the same. Okay, so that's a real big clue. Okay, if you hear anybody talk about equilateral triangles, it means that they are a triangle where all of the sides are the same, but also when you come to it probably next year, all the internal angles will all be the same as well. So the sides are all the same, and so are the angles. On an equilateral triangle, all of the angles are acute angles. Now, the second section there, it says only two sides are of equal length. So with these two triangles, okay, you've got this side and this side are the same. And on this triangle, this side and this side are the same. Now, we call that type of triangle, and this is a big word, an isosceles triangle. Isosceles. So isosceles triangle has two sides the same. Okay, two sides the same. And what I would say as well is that you have two sides the same, but also these two angles will be the same as well. And they are always, on an isosceles triangle, they are always acute angles. So two sides the same, or two sides that are equal, isosceles. Now, the last one is where all three sides are different. They're all different lengths. Okay, and that's something that we call a scalene triangle. Scalene triangle. So when all three are different, we call that scalene. So now it's your turn. In a scalene triangle, all three sides have different lengths. Which of these are scalene triangles? Which of these are scalene triangles? Press pause now while you're looking. Press play when you're ready to hear me talk about it. So press pause now. Okay, welcome back. Right, a scalene triangle. So straight away we know that a scalene triangle has to have sides, all three of them, different lengths. If I look at shape F here, each of those are of different lengths. So this triangle is a scalene triangle. The other thing that this triangle has is a right angle. So I would say it is a right-angled scalene triangle. Shape G is not scalene. Okay, this side and this side are both the same. And if they're both the same, then that makes this triangle an isosceles triangle. So shape G is an isosceles triangle. H here is a scalene triangle because all three of these are different lengths. These two are quite close in length, but they are different. Okay, and this one is clearly longer. So this one is a scalene triangle. And this last one here, well, that cannot be a scalene triangle, and hopefully you'll have picked up that the reason it can't be any type of triangle is that it's got four sides. It's a quadrilateral, not a triangle. So that cannot be a scalene triangle. Okay, next question here then. In an equilateral triangle, all three sides have the same length. So which of these are equilateral triangles? Which of them are equilateral triangles and which of them are not? Press pause now while you're thinking about it and press play when you're ready to resume. Okay, so let's start with the yellow one, shape L. This is an equilateral triangle, nice and easy to pick. All sides are clearly the same. So that one is equilateral. We'll look at J over here next, okay, the blue triangle here. This one is also equilateral. What we've tried to do here is make it more difficult for you to tell because they've rotated it slightly. So they've turned it a bit so that it's difficult for you to check it. If you get that kind of question, don't be afraid to turn the page. Don't be afraid to turn the page round, okay? And then sometimes it'll be easier for you to spot. So that one is equilateral. K, well, hopefully you've picked out that this one is a parallelogram. And if it's a parallelogram, it's not a triangle, it's a quadrilateral because it has 4 sides. If you wanted to be really clever, you might turn around and say, well, actually, it's not an equilateral triangle, but if I drew one line across, so if I went here and drew one line across, actually what you'd get then are 2 equilateral triangles. But the shape on its own isn't a quadrilateral, it's not an equilateral triangle. And the last question, the last shape, sorry, here is shape C here, and this one is an equilateral triangle. Okay, again, you might want to rotate the page just to have a look at it more clearly, but it is an equilateral triangle. So we have 1, 2, 3 of them that are, and this one in the middle was not. Finally, for your guided practice this morning, you've got 4 triangles there, and it's saying there, could you work out which of these triangles are isosceles triangles? So which of them are triangles that have 2 sides the same? Press pause now while you're having a look, and press play when you're ready to listen. Okay, so let's have a look up at J here. Now, we said we're looking for isosceles triangles, triangles that have 2 sides the same. This is not isosceles because it has all 3 sides the same. It is equilateral, like we looked at just now. So this is not an isosceles triangle. M here is an isosceles triangle. This side and this side are both the same. This one is different, therefore the shape is isosceles. If we wanted to look at shape N here, the red one, this is also isosceles. You might have needed to rotate the triangle slightly to have a look at it better, but this side here and this side here are both the same. Okay, 2 of them are the same, therefore they are isosceles. And finally, this shape here, this triangle here, this is not isosceles. All 3 of these are different lengths. If they're different lengths, it must be scalene. Okay, and you might have wanted to move on and have a look at drawing another isosceles triangle of your own. If you did that, brilliant. That was a little bit of extra for you. Okay, our independent learning this morning, I'd like you to complete worksheet 3 on pages 126 to 128 of your workbook. Press pause while you're working and then press play when you're ready to hear me finish off the lesson. Press pause now. Okay, hopefully you're able to work through the worksheet this morning using some of the knowledge that you will have gained from the lesson. Have a lovely day. I've not got a plenary for us today, and I'll speak to you tomorrow. Thanks a lot then. Goodbye.